Uh, I'm discussing about radioactive series. There are four types of radioactive series: thorium series, uranium series, actinium series, and neptunium series. First three, thorium, uranium, and actinium series are natural series, and last one, neptunium, is artificial series. The radioactive series, also called as radioactive decay series, is the series of elements obtained by successive disintegration of a parent radioactive element to a non-radioactive stable element. The series of elements obtained from thorium 232, uranium 235, and uranium 239 are natural radioactive series, while the series obtained from artificially prepared neptunium 237 is called uh, artificial radioactive series. First of all, thorium series, it is also called Fourier series. It begins with the radioactive elements uranium 232 and ends with stable non-radioactive lead 208. The mass number of all elements are integral multiple of 4. Uranium 4n plus 2 series, the parent element uranium 238 is used as its starting parent radioactive elements, which undergo disintegration and form lead 206 as its final stable component. Since the mass number of all elements in this series gives a remainder of 2 when divided by 4. It is called the 4n plus 2 series. When n is an integer, it possesses the longest half-life. Actinium series 4n plus 3 series, the radioactive element uranium 235 converts into lead 207 or stable element as the final product. The mass number of all elements in this series gives the remainder 3 by divided by 4. That's why it is also called 4n plus 3 series. N is the an integer. Neptunium series 4n plus 1 series, it is also called artificial series. The elements in this series are not found in nature. It begins with the bismuth 200 and terminates into stable neptunium 237. The mass number of all elements in this series gives a remainder of 1 when divided by 4. Hence, is called the 4n plus 1 series. The thorium series, 4n series, the thorium 90 232, when alpha, it gives thorium 92, when the alpha, the mass decreases by the 4 units and the atomic number decreases by 2 units, that is the alpha disintegration, and becomes 92 decreased by 2 numbers, 88, that is the radon, and the mass 228. And the beta disintegration, the mass is the similar, but atomic number increases by 1 unit. That's why the 89 is 89, again beta, and thorium 90, again alpha. The mass decreased by the 4 units, 224. That is the radium. That is the radium, and the mass atomic number is decreased by 2 units, that is 38, and the alpha disintegration, it gives Rn 220, atomic number 86, that is the radon, and alpha disintegration, it gives the it gives the polonium. Polonium, the atomic mass number is 216, atomic number 84, and beta disintegration, the mass number increases by 1 unit, that is the 35, 85 statin, the mass number 216, and in alpha disintegration, it becomes the atomic number decreases by 2 units, and 85 to it becomes 83, that is the bismuth, and the atomic mass number also decreases by 4 unit 212. In another way, the polonium alpha disintegration, it becomes the 4 unit decrease by the mass and becomes the 212, and the atomic number decreases by 2 units, that is the 84, that is the lead. Again, the beta disintegration, it becomes the bismuth, and this is also again the two ways, and the alpha disintegration, it gives the mass number decreases by the 4 unit 208, and the atomic number decreases by 2 unit, the thallium, and beta disintegration, it gives the lead 82, the mass number 208. In another way, from the bismuth, beta disintegration gives the 84 polonium, the mass number at 212, and alpha disintegration, it becomes 208 lead. This is the 4n series. The uranium series 4n plus 2 series, it starts from the uranium 92 238, and alpha disintegration, it gives the mass number decreases by 4 units, that is the 234, and the atomic number decreases by the 2 units, it becomes 90 thorium, and the beta disintegration, uh, the mass number increases by 1 unit, and it gives uh, it gives protactinium, protactinium, and the atomic mass number is 234. And again, the beta disintegration, it gives the uranium 92. In another way, it starts from the neptunium 93 to 238. Beta disintegration, it gives the polonium, sorry, plutonium, and alpha disintegration gives uranium. And again, alpha disintegration, it gives 230, thorium 90, and again, alpha disintegration 226, uh, radium 288, and again, alpha disintegration, it gives radon 36. And again, alpha disintegration, it gives polonium 84, 218. Two ways, alpha disintegration and beta disintegration, it gives astatine and lead. And also again, alpha and beta disintegration, it gives bismuth. Again, from here, alpha and beta disintegration, it gives polonium 84 and thallium 81. Again, alpha and beta disintegration, it gives the lead lead 82 210, and the beta disintegration, it gives 83, the bismuth, again beta disintegration polonium 84, and alpha disintegration, it gives the 83 209. Actinium series, it starts from uranium 239, and it gives the beta disintegration, it gives 93 neptunium, and the beta disintegration plutonium, again alpha disintegration, the mass number decreases by 4 units, and the atomic number decreases by the 2 units and becomes 92, that is the uranium, and again alpha disintegration, it becomes 90, that is to thorium, and the beta disintegration, the mass number increases by 1 unit, proactinium, and alpha disintegration, it gives actinides, uh, actinides 89. Here also, alpha and beta disintegration, it gives thorium and francium, and alpha and beta disintegration, it gives radium, and alpha disintegration gives uh, the radon, the mass number decreases by 4 units, and atomic number increases by 1 unit. Alpha disintegration, it gives polonium 84, and alpha disintegration, it gives lead, and beta disintegration, it gives bismuth. Again, alpha and beta disintegration gives polonium and thallium, and alpha and beta disintegration gives lead. Okay. Thanks for watching. Thank you for your patience. Bye bye. See you again.